Welcome back to the Building HVAC Science podcast, where we are working hard here to create better, more knowledgeable HVAC and building performance technicians by helping the two professions better understand each other with the ultimate goal of making customers happy in the homes they live in and the buildings they work in. One of my friends, Buck, from a long time ago, called it, "Bill, you're always in search of kumbaya." Well, in this case, this is a legacy episode, I'll call it. Eric Kaiser's dad, Mark Kaiser, joins us for a special discussion where he talks about his journey, which began in the late 1970s, retrofitting a very modest house to reduce energy consumption using some really unconventional methods. He continues to work on the house to this day, and we also get into a little bit of the topic of DC or low voltage systems, 12 and 24 volt setups, and the environment that Eric Kaiser grew up in. Mark really has a deep understanding of thermal mass, energy usage, and alternative construction methods, and he's created a very thoughtful, sustainable home design. So let's get into this conversation as we learn about building a legacy, energy efficiency, and innovation with Mark Kaiser.
Hey everyone, welcome back to the Building HVAC Science podcast. Eric Kaiser here, Bill Spohn right over there. And with us today, we got a guest that's pretty special in my life. My dad, Mark Kaiser, is here with us, and we invited him on the show because I started telling Bill one day about the house that I grew up in. And Bill, you were really interested in that, so welcome.
Yeah. Hey, Mark, thanks for coming on. This is fantastic. First time we've had father and son on our podcast in 188 episodes, so you just broke ground here. Thank you, sir. Why don't you just start at the start? Tell us who you are, what you're doing, and then where your ideas for building performance and energy came from.
My name is Mark Kaiser. I worked at repair shops for many years, and then I put on at Blackburn College and was in charge of utilities, which is anything with pipes or wires coming out of it. So I did boiler work, plumbing work, toilets, lights, building energy. I watched all the new construction out there, and actually that was part of the house here. Eric was, just a young little tot and probably didn't realize all that was going on around him at the time. I originally rented this house from a fellow that lives down the road from me right now, and he said it doesn't use very much energy in the winter. Well, the first cold month, my energy bill was a whole lot higher. I think it was $150, which in that time, I bought the house for $6,500. So $150 was high. And I crawled up in the attic and I insulated it, and I more than saved that money back that winter, even though I was renting the house. I eventually bought it. The house was built in pieces. It was originally a 2-room lawyer's office. And so the roof line went in 3 different directions, and there was a valley in between, and valleys always leak. The guy before me had to work on it. So I decided I was going to change the roof line. And the question came to me, well, what about solar? So I have a house that faces south. We have a bay window right behind me here that brings in some nice heat in the winter. I got some of my ideas from Mother Earth News. I picked up, bet you it came from my dad. It's council notes from the Illinois Locale House from the University Illinois at Urbana, which suggests that you have a double wall construction. Put 2 walls outside each other, offset the studs, insulate the heck out of it, insulate the heck out of the basement and the basement walls. This house turned out that there was a course of brick laid on the ground and 2 courses of concrete block. That's the foundation for this house.
What was at that time?
What was at that time, yes. And I went, well, this isn't going to hold up any length of time. So we slowly dug around the house by hand, put in the proper footing, I used concrete block, and this is where Blackburn came in. We were building a building at the time, and I hired a couple of the students to come out and show me how to lay block.
Can I interject something here? I just want to say, it wasn't just digging around the house. You actually jacked the entire house up and supported it at that time, and then put a whole new foundation with footers like 8 feet in the ground.
6 feet, yeah. I didn't jack the house up as much as I put some old barn timbers in the basement and outside and just held the house up while we dug under it. I actually, for the top course of block, I poured my own block size but 2-inch thick pieces to go on the top to help seal the top up so the termites couldn't come up, and termite shield on top of that. So that was the first part. The second part was extending the house 2 feet on the south so that I could get the roof in. And I knew the stairs, there were no stairs in the house. It was a 1-story house. So I was going to build a second floor. So part of this double wall worked out really nice in that I could leave the house as it was and build the second wall around the house. So I wasn't tearing out anything. In the living room, that actually straightened things up because the original wall tilted in 2 inches and 10 feet. The new outside wall ended up being straight. That gave me a lot more room for insulation at the top. So we put the footings under the house, the block, started building. We built the second floor on the back side, and because I had this new outside wall, I was able to construct the new roof over top of the old roof. And then we have pictures of us doing the roof tear-off with a new roof over top of us. It came out, I ended up with a gambrel roof on the back side, a barn-style roof. So the south-facing side, I put on call wall first, 40,000th inch fiberglass reinforced. And eventually I put, it's a double wall. I don't remember the name right now. It's a double wall.
It was a greenhouse panels, wasn't it?
Greenhouse panels over top of that. And I've never had any leakage problems. That's worked out real well. So it's actually triple wall on the solar side in the solar heat gain. So on the second floor, there are rooms in the center, but on the south side, I'd have to send you diagrams. There's a low area and a high area that are collector areas. They get heated. There's a blower upstairs that blows the hot air down into half of the basement, which is only like 4 feet down, and it's filled with milk jugs full of water to retain the heat.
Okay, couple questions here. Just to orient our listeners, where are you located? Because climate zone matters a lot.
Correct. This is Carlinville, Illinois. We're north between Springfield, Illinois, and St. Louis, Missouri.
Okay.
Right on the border between climate zone 4 and 5.
Okay. And the milk jugs, you got to give me a date here because they're made of plastic now. They used to be made of glass.
They were made of plastic then, too.
Okay, plastic.
Some of them have deteriorated and they'll leak out and replace, but there's a concrete floor with a drain in underneath it. So if they leak out, I'm not hurting. Matter of fact, in the winter, that brings more moisture into that place.
You started this process in the late 1970s?
Yeah, we were married in 77. So that all happened after that. The shed, of course, was first because I had to have a place to store things. There's a couple of things built into the house. There was a building at Blackburn that was made out of plaster block. It's the only building I've ever seen it. They're about 2 foot long, about 8 inches tall, with vertical cores in them. And they were cemented together and then plastered on both sides. The whole building, the whole dormitory is made out of this. And I got a hold of some of those old block and I set them in between the studs on the second floor to act as thermal mass up there also. So there were a couple little things that I tried. The whole house is tempered. When we do anything with it, it takes a while to respond. It's gotten a little cold here. The neighbors are already talking about turning on their furnaces. We haven't done a thing because the house is staying nice. It's staying about 70, 72, just with the sun coming in the windows. In a short period of time, this collector area that I've got has vents in it, both low and high. So during the summer, we're sucking air in on the low roof, and then we're venting it out through, there's 2 peak vents, and there's what you'd put on a barn with the square silo kind of
Cupola vent.
a louvered vent in the center. So I have 3 ways to take the air out. So I'm flowing the air through there. During the summer, that gives me a nice warm room, so I use that for dehydrating food. I just have some little racks in there and a couple of fans. During the winter, there's a little shelf in there, and we can climb up in there and let the sun warm us. So there are little things that we can do that other people don't. That's not of an interest to the heating. So during the winter, I close the high vents. I just have ropes and weights on the end of them. I unhook the weight and let it drop down, shut the doors, and then I put seals in the bottom. and I turn things on. I have a thermostat up there set about 80 degrees and a photocell so that the fan comes on during the day when it is light and when it is warm. And so it will shut down at night when the sun goes down, because at that point it may still be warm, but that may be sucking heat up out of the storage area then and re-irradiating it out.
You have a really fantastic grasp of thermal mass, thermal gain, thermodynamics. How do you think you developed this?
A lot of reading. I've read widely in many places. There was a gentleman had been in the Korean War, and he told me the way they heated their houses out there was they had hollow tile through the floor, and there was a fire pit on one side of the house outside, and then the smoke was conducted up through the floor and out a chimney on the other side. I was concerned about also electrical. I know from working at the college and working in electrical for many years, we as a society have built a pyramid, and the electrical is on the bottom, and then we can build radio stations on top of that. We build telephones on top of that, but the electricity is down at the bottom. And I had enough trouble at the school with electricity failing just from squirrels climbing up and shorting things out. It happened once or twice a year for a while. The power company finally put some decent insulators on that squirrels can't get in there anymore. So the other thing I did with the house was I put on photovoltaics on top of the roof. And it ends up that the slope of the higher roof is actually correct for this area in the summer. I should lay the panels back. But I'm using more electricity in the winter than I am in the summer, so I don't bother. It's up there, it's available. So the panels sit above the slope of the solar heat, and they're all at the same angle. It's about 54 degrees, I believe, at this area. And I use that, and we're not doing any cell back. It's 24 volt. I have battery backup in the basement. There's an inverter on that if I want, but I have found a number of things. I have also, so I've got 24 volt DC. I have a unit that can reduce that to 12 volt. And I have 12 volt in every room of the house. Eric remembers when he was a boy, he had ham radio equipment up there, and he just plugged into the 12 volts on the wall and had his radio actually mounted. He was in a bunk bed. He mounted everything up on the bed above him. That's cute. I can do things like that. But I have found since then that there's so much in 12 and 24 volt that's available. Originally, I put the freezer on this. We had a Montgomery Ward's small chest freezer, and the solar could not keep up with it. I was draining the batteries all the time. I bought it's called a Sundazer. It's actually made by Electrolux. Chest freezer that runs on 12 or 24 volts DC. You give it either, it knows what to do with it. And it just sips electricity by comparison. And we've run on that for 20 years now. Through the house, I really can't show it to you, but I can turn things on here. I've gone into strip LED lights. They're mounted under the edge of the counters here and in the kitchen. There are companies that make screw-in 12 and 24 volt light bulbs. I have considered on going, and you can get 24 volt ceiling fans. I've considered going around to all the lighting in the house and turning it into 24 volt. I haven't. So the solar provides us electricity for part of the controls in the HVAC. I've got a couple of louvers. They're Belimo. Belimo will run on 24 volt DC. The doorbell's on 24 volt. The answering machine, because I have 12 volt here, I have a cord that I can plug my modem into if the power fails, and I'll still, as long as it's coming down the pipe, I can still run this end of it. It runs the freezer in the basement, runs radios. I've got just mounted a car radio down in the basement in the shop, so I've got radio down there. And then the inverter runs all the house lighting and the outlet for my wife's hair dryer. So she gets to dry her hair from the sun.
Where do you find the outlets, the wiring? What type are you using there?
All right. Originally, I was very concerned with voltage drop. So the wiring that I ran was 10 gauge, standard Romex through the house. But I find now with doing the LEDs, they draw so little current, I don't have to worry about that. So all my LED lighting is run on like 16 gauge wiring. The outlets that I found are I don't have an object lesson here to show you, but they're actually a European twist lock. There's a peg in the middle and the wipers are on the outside. You put it in and twist. Oh, wait a minute. I do have something right here. One of the reasons for the solar was I'm a ham radio operator. So these look very much like a speaker con, but it's a European model. They have two, so I use one for 12 volt, one for 24 volt. In the National Electrical Code, it says that you're supposed to have a twist lock, so this is actually better. Most places say just get a 240 volt outlet with straight plugs and use them. I find that this is quite acceptable here.
And it does sound like you've mentioned the code and things like that a couple times. Sounds like you're really paying attention to safety, reliability, durability in what you're doing.
Yes, everything is not put in cobbled up. I've seen cobbled up houses. This one, I've got everything nailed up, set aside, run straight. It looks pretty nice in the basement. I'm familiar enough with the code from working at Blackburn. I had the code books there and was able to check back on them for voltage drop, on line loss, and all kinds of stuff like that.
Is there anything new you're working on now you want to talk about?
What I'm working on now is what I found from the building. Now I've lived in it long enough that I'm getting feedback from the house. First of all, the double wall construction sounds good in theory, but being fiberglass, you understand that fiberglass is nothing more than a filter. With the studs set cattywampus through, the wind blows sideways through the house. Your fiberglass is only good if you have it in a sealed box unit. The council notes here suggest the two walls separated slightly so that for moisture ventilation, you didn't get moisture in the middle. However, any little hole or air leak or where the wire goes through or the piping goes through, now the wind blows through. I ended up tearing off the siding, which was giving me some problems anyhow, and I went back in and put styrofoam in the outside sections of the wall around the house. And then I went back. I had black boxing on it. I put 1/2-inch plywood on it. That seals the wind out much better. Now, I know Eric has talked to me, and I've read some about putting insulation on the outside of the house and taping it up and everything else. So would I do anything different? At this point, I like the double wall construction. There's a sense of security. It gives us ledges on the inside. We put the windows in the outside section, and then there are ledges for setting plants and whatnot. But it also gives me room to put in the vertical bifold blinds. They're a cloth blind, and you can get them that they have seals on the edge to seal out the light. Well, that seals out the wind, too. So there's enough room in there. Most of the windows are equipped with a roll-down shade right against the window, keep the sunlight out so that it doesn't deteriorate the cloth. And then the next one has the room darkening, and the inner one has a light shade. So we have, how do you want to set up your windows? Do you want to set it up for cold? You pull all three of them down. You want just diffused light? You put down the inner one, or it comes down from the top. You can look out and have the sun not shine on the floor and the rug. So that gave me a lot of options in how we do not only heat control from the window, but interior decorating. There are different colors on the different shades.
Very cool.
That's something that you wouldn't get without a double wall.
No, you'd be really constrained on that.
That's what I'm saying, that I've had a chance to play with this now that I built it.
Eric, you got to have some observations here.
There's a lot of observations, and I mean, he gave a really good high overview of the house and nitty-gritty in a couple of areas. Let's talk about how many heating systems do you have in the house?
Well, now, you see, Eric even helped me here.
Okay.
The primary heating system, as you would understand, was solar. Part of my reason for going with the additional insulation was I thought I would do the solar, which means I've got to be able to keep the heat because you don't get the kind of BTUs off the solar that you can out of natural gas or anything else.
And it's not on demand.
Yeah, it's not on demand. You've got to have enough thermal mass that you can make it through the night because you got to get the heat in the day. And I realized it would not do 100%. So there is a wood stove that's currently mounted in the living room kitchen area, which can heat the house. Eric put us in an air conditioner, which is a Mr. Slim split unit. So I can heat with electricity. I can heat with solar, but I have to have electricity for that. I can heat with wood. And then, being the boiler man that I am, I took an old rude 15-gallon water heater and put boiler controls on it. So there's an outdoor-indoor reset thermostat. There's a high limit on it, of course. That is gravity fed into a coil that's mounted horizontally. So I can bring the piping in high, go through the coil, return low. I let it just gravity feed. There's no pump. The controls are all on millivolt controls. So as long as there's natural gas, that also works. There's a blower down below it, but that's mounted in the heat storage area so that I get some of the heat from the jugs, and then I have this auxiliary laid in on top of it. So I split between the two. Heating bills here, usually I have not ever hit $100, and we have combined electric and gas utilities, so I'd have to go back and look and break it up. But my average was $89 a month, gas and electric, for the past year. This year we had to throw in a window air conditioner for some friends, so it's going to be a little higher.
With all this going on there, maybe your neighbors, maybe more people know about what you're doing. Has anyone ever asked you to do something like that for them?
No. I have offered in a couple of places to help put in strip LED lights. I think they're wonderful. They bring the light right down where you want it. Under the cabinets in the kitchen, you've got it right there where you can see. Put it underneath the railing that goes up your stairway. Your stairs are always lit. They're never in shadow. We have it on top of a cabinet in the bathroom. The indirect light is great at night because you're not getting this bright light in your eyes. All kinds of neat little things. Now, Eric and Rachel put multicolored lights over their cabinets, and they can give you a light show just sitting there eating dinner. That's not what I'm doing.
Did Eric mention to you our conversation with Derek Coburn?
No.
Not yet. We haven't discussed that one.
Okay. We had a fellow on how would you describe what Derek's got going there?
He's reinventing the current lighting system a little bit, but also integrating it with a lot of other controls in the house so that it's a much more of a centrally controlled house. And Dad will understand this because one of the things that he did while he was at the college, and I can remember this growing up, was he actually instituted a campus-wide energy management system, which then led into a building management system or building control system over the whole campus. And I think they started out looking at energy usage and picking off the big things and trying to load shed down because of the rates. But then that morphed into more and more as the mechanical systems on the campus have grown, and they can do central lighting controls in a lot of the areas.
One big thing with what Derek's doing, it's DC, all DC.
Yeah, but Derek's doing everything in DC, so
I'm right there with him. Eric is correct. The energy management system first came in due to electrical peak usage. The Illinois Power was the company at the time, and we were having to pay extra rates based on our peak usage for the year. So the problem was we have 16 major buildings, and doing load shedding is very time precise. We could set timers around campus. They were mechanical timers. There was nothing coordinated close enough to be able to do the load shedding that we needed. So this system we got started out with Honeywell equipment. It now is Opto 22. The software was Alemco out of New York, and it has worked beautifully. It started out DOS, and now it's Windows, who knows what. The system has run extremely well for us for many, many years. And it allowed us to do the shedding that we wanted to do, but we also take building temperatures, run the boilers, load shed water heaters, so that they're also timed out so that we don't build up energy there. And in some of the later buildings, they added lighting control, and we can integrate that into the system. It was designed to handle anybody's hardware. Now, as companies have become proprietary and done their own, we're having a little trouble interfacing with their electronics, but we can always go back to a thermostat and work with it from that end.
You handed up or put in front of the screen this Low-Cal House Council Notes. Is that something that's currently still available?
Heck, I wouldn't know.
I bet we know some people that could tell us that.
Yes, this was C2.3. C is in Charlie 2.3, Volume 1, Number 4, Spring of 1976. 25 cents.
And it's published by whom?
University of Illinois at Urbana-Champaign. The Small Homes Council Building Research Council.
I'll bet you your friend Ty Newell knows something about that, Bill.
Yeah, I would say so because I think he was teaching back there then too.
Yeah.
I'd like to, if something like that is available, some people are listening or curious about this, they could maybe start down that path that you've been on for 40 years.
Well, I think this was the beginning path that a lot of the things that you're doing now, like putting the insulation on the outside of the house, if you read this, this will give you the background as to where it came from.
Absolutely.
Yeah. So we actually had a discussion the other day in amongst a group of us. Somebody asked about heat pipes or the buried pipes in the ground. And I know one of the things you did for ventilation air, especially because you needed combustion air for the wood stove and building that a little bit tighter house, you've got 2 tubes that come down and into the basement from underneath the crawl space side or the solar storage side of the basement.
Correct.
And how do you feel those have worked? I mean, obviously they're bringing in air almost constantly if you have air coming out the top of the house somewhere, whether it's going out the stove or going out somewhere else, you're bringing in air there. How do you feel those have worked? And have you done any testing on that for heat transfers to how well they actually transfer heat into the air to either warm it up or cool it down?
All right. The original thought pattern in the article that I got it from, they were calling them cool tubes, and they were using them to cool houses in the summer. I did not put in linearly enough feet to be able to cool the air enough, but it does temper the air coming into the house. I am all for it, especially I was in a house just recently where the people were sick and something else, and I happened to go to their dryer to help them out. I was just going to take the clothes out, and I found there was a downdraft on the hot water heater. And I thought it was caused by the dryer, but I shut the dryer off to take the clothes out. It was still downdrafting. The furnace was running for air conditioning. So it was air conditioning season. The furnace was running. Somebody had put a vent out into the garage, so it kept the house at a negative pressure. They had been pulling CO down from the water heater flue for years. These people were sick because it was a sick house. And that made me more glad that I had these tubes coming in. Eric will tell you he was a little upset. One of the tubes, I ran over to the dryer so that during the winter, I could put the dryer through the tube and then bring it back into the house. And he kept complaining that his clothes smelled of mold when he left them laying in the dryer for a while. That is disconnected, but I do feed the dryer is electric. And during the winter, I've got a filtration system and I feed that moisture back into that solar collector room. So we pick up the moisture from that in the winter, and then during the summer, I flip it back outside. But the cool tubes do provide me with combustion air, with breathing air. The stove actually is constantly venting out even in the summer because it has a stack. It's going to lose some out there. So I see this. It brings it in somewhat conditioned. Then it goes through the basement and helps warm it up some more. So I really don't have a problem with cold air coming up like you would if you just brought it through a wall next to the furnace or next to the heating stove. I like it. It's worked well for me.
Have you done any actual temperature testing to see like how much of a temperature rise you get out of the tempering the air? No.
No, I have not.
How about mold? You mentioned the mold issue or some growth issue in there. Have you looked in those to see if there's anything growing in them?
Yes, I've brushed them out once because I had trouble with water coming in. My joint outside pulled apart. This is one of the problems. These are 8-inch plastic pipes, and the joints pulled apart because of the heave of the frost heave lifted the pipe up and broke the joint underground. And I've got that problem again. I'm going to have to dig it back out and find a different way to make sure that it stays sealed. Eric put us on to that we should keep the basement at 50% relative humidity. So I have a dehumidifier down there. And during the summer, I know that the pipes don't take out all of it. There does not seem to be a lot of growth in there. I'm not having a mold problem. The basement is much better off. Thank you, Eric, for suggestion of the dehumidifier. That works well in the summer. Again, and that's even in on that electrical use and energy use that I talked about earlier. So I'm working fine with that. The Mr. Slim, you can barely see it on the wall back behind me because the way the house is built, that does all the air conditioning for downstairs. Eric would know the BTU rating of it. I don't.
It's either 12 or 15.
And it very comfortably keeps the whole downstairs
Sure.
cool.
Ton and a quarter.
Yeah.
So you can see that the insulation does do something.
Yeah.
Let me just ask this question, because this is a big thing that comes up in some of the industries we touch. What's your square footage on that first floor?
Oh,
Rough guess.
I think I've got 1,800 total.
So you're probably at 1,200 maybe on the first floor, probably 1,200.
At the most, yes.
Yeah. Doing that with I think that's a 12,000 unit if I remember correctly. So a ton. So there's, for all you people out there listening, 1,200 square foot per ton, and it handles it just fine. It'll make it cold in there. I don't think that thing's ever running flat out.
It even keeps up in the summer when I'm doing canning in the kitchen. It is enough to take the moisture out and keep the house cool.
So it's oversized at a peak load.
So usually as we wrap up with our guests on the podcast, we say, how can people reach out to contact you? But I'm just going to say, they'll contact Eric and then he'll get you if you need to be. I did happen to look up here. It says that the Small Homes Council notes, as you mentioned, are available at the University Library or the City Planning and Landscape Architecture Reference and Resource Center, but they're not digitally available, but they might, when requested, might make them available. So I'll add some notes to that extent in the show notes because I think that's an interesting piece of history you've brought up here.
A lot of the other ideas are mentioned or brought up in Mother News. I've read that for years, and I get little tidbits here and there, and I put them together in ways that maybe other people don't.
Yeah, it's through your creative mind that this all was born. And that guy was born too, right?
Hey, everybody gets to see what I grew up with now and why my brain is the way it is.
He's got a lot of background. My father was a nuclear physicist, and his other Gramps was an engineer for Serdup and Parcell down in St. Louis, construction firm.
Awesome.
He's got a lot of brain power to get started with.
Natural, fertile soil there. Mark, thank you so much. Real pleasure meeting you and hearing your story and all the paths you've taken things down over time, and really appreciate the chance to get to know you a little bit better. And I hope our listeners did too.
Now that foam is available, I took out some of the fiberglass up around the heat generating area on the top and had that foamed. And that made a big difference because the foam seals in all the air leaks, which the fiberglass cannot. However, I'm finding now that foam has shrunk in some places and is pulled back. So it is not the 100% answer. No matter what you've got, you're going to do it, and you're going to find you're going to create new problems. Good luck.
That's a good way to end things. Keeps us all employed. Thank you, Mark.
You're welcome.
All right.
Thanks.
Thanks again for listening to this episode of the Building HVAC Science podcast. Sometimes the topics we discuss require technical training for proper interpretation or safe execution. So if you're a trained pro, go ahead and do it. But if you're not, please consult with and hire a trained pro. The Building HVAC Science podcast is a production of TrueTech Tools. And full disclosure, I'm the owner of TrueTech Tools. And the opinions voiced are those of my guests, my co-host, and myself, depending on who is speaking, of course. We didn't cover too many HVAC test products in this conversation, but if you're in the market for them, take a look at what we offer at TrueTechTools.com, TrueTechTools.com. You can use the offer code HVACBS for a nice discount. I want to thank you for listening to this podcast. Hope you subscribe to it. And we hope we're doing you a service in keeping you up with the world of building HVAC science. Take care.